Can you all hear me?
We can hear you.
Oh, perfect, perfect, perfect. Good morning, everyone, once again. So we're trying to put up the screen. I heard the moderator had some issues sharing our screen, so I'm trying to. So I don't know, is anyone on now that can help with that? Patrick had reached out, had message. I'm not sure you've seen my message. Patrick, are you good to help share your screen instead in the moderator stead?
Yeah, can you hear me?
Yes, I can hear you.
All right, let me try to share my screen.
All right. I've shared the slide deck with you already. Thank you so much. And I can see our facilitator on call already as well. Chinedu, thank you so much for making our time to join Hedy. Yeah.
So you have to um enable me share.
Oh yeah. Oh, okay. Which of your lines? I see that you joined with two different lines. Which of them? Or let me just make both of them. Either way works.
Okay, let
Co-host.
me try it.
So you're co-host now, so you can please go ahead to share your screen. Um Welcome Ijeoma, welcome Jude, welcome Williams. Right. So we could once we have the screen on, we can. So let's try to reach out to our members. I know today is Saturday, but let's just try to quickly reach out to remind more people, members to join the call so we can have a brief session and call it a day. Thank you so much, everyone. Welcome, Fitia.
Hello, Mr. Lucky. Good morning. Sorry, good
Mm.
afternoon. Thanks so much.
Yeah, good afternoon.
Oh, please confirm you can see my screen.
Yeah, we can see your screen, but the slide deck is not on yet.
Hello, Paul.
Yes, your screen is coming up. It was on, but it's not. Okay, it's coming up again. Yes,
Is
can you
it
put it
on
on
now?
slideshow? Yes, put it on. Okay, perfect. Yes. Thank
Okay,
you so
just
much. Okay.
let me mute.
All right. All right.
Okay. Good afternoon, everyone.
Good
Please let's
afternoon.
confirm. Thank you. Good
Can hear you.
afternoon, everyone. I hope you're all good. On behalf of SPU Warri Section 104, I warmly welcome you all to today's session. My name is Victoria Oyewo, and I'll be your moderator for this event. So thank you so much for making our time to join us. So today's session is themed data analytics for oil and gas operations. I think it's a popular word that data is the new oil, but as much as data is the new oil, it requires the right tools to refine it. We're in an era where decisions in oil and gas, we don't just do it by my mind say, or we use our intuition or our observations. We have to use data-driven decisions too when we're making some decisions in oil and gas. So, and we see it in our everyday oil and gas operations from our production data, our performance metrics, our maintenance data. They all give us data to analyze to make informed decisions. So, in today's webinar, we understand what data does, how to interpret it, and how to use it strategically. So, once again, welcome to today's session. And if you're so excited to be here, can you just drop some reactions, emoji, your favorite emoji to show that yes, I'm pumped, I'm excited to be here, and I'm so happy, and I look forward to today's session. I'm not seeing our reactions. Thank you, thank you so much. Thank you so much. Next slide, please. So before we begin, I'll briefly walk us through the order of activities. So we'll start with a safety brief, which will be taken by Jude Alele from SP Worry section. After that, we'll be having our opening remarks delivered by our career and technical lead, Paul Alawi. Please, Paul Alawi, can you please say hi? Signify to us on the call.
Yeah, I'm here. Hi,
Thank you so
everyone.
much.
Thank you.
Thank you. You formally set the tone for today's session. So, and then we'll move on to the highlights of today's event. That's a technical presentation, which will be delivered by our guest speaker, Mr. Chinedu Nweke, CEO of TechieCraft. Following the presentation, I will moderate the question and answer session where you will have the opportunity to engage directly with our speaker. Then after the Q&A, we'll proceed with the presentation of certificates, which will be handled by Hedore Ogeneworo. We will then have a brief photography session, so please be ready to turn on your cameras. So next we hear about SP awareness and upcoming events from Patrick Akwagu, so you can stay informed and connected to SP Worry section 14. And finally, we'll conclude our closing remarks and vote of thanks, which will be delivered by Ugo and Yelose. So this session promises to be very insightful and practical. It's even going to be a live workshop. So I encourage everyone to stay engaged and participate actively. With that said, we'll begin our safety brief. I now invite, next slide, please. I now invite Jude Halili to take us through it. Jude Halili, please signify you on the call. And
Yes, Victoria, I'm here. Good morning,
thank
everyone.
you. Good morning.
Sorry, good afternoon. Yeah, we're already like past midday. Yeah, so good afternoon, everyone. So before we begin our technical session today, I'm privileged to run us through a few safety guidelines that would ensure that we have a very smooth and safe engagement. This next slide. Yeah, so as you can see on your screen being displayed, one of the first things I want you to do is that you need to mute your microphone when you are not speaking. This helps us to be able to minimize any kind of like background noise or distractions while during the course of this session. If you would like to make a contribution or maybe you want to be able to flag something, you can signify by raising up your hand. And Victoria here, who is the moderator of the day, would be able to call on you to make your points. We'll also be able to make use of the chat button where we have opportunities to be able to make comments and also ask questions where applicable. If you are in a workplace environment like myself or others here, ensure that while your earphones are plugged in, you're still able to hear fire alarm just in case there is need for emergency evacuation as a facility where you are. Be alert of your environment, so put an eye out there even as you are listening, and also maintain a good sitting position because we don't want you to have back pains at the end of this very rich, packed technical session that we have. Above all, please always stay alert and be aware of your surroundings throughout the session, whether you're at home in the office or on site, because we want you to ensure that you are aware of the situation around. Thank you all. Over to you, Victoria.
Thank you very much, Jude, for that important reminder. As we know, safety is very important and is our culture here. So we'll now proceed with the opening remarks. It is my pleasure to invite our career and technical lead, Paul Halabi, to address us. Paul, over to you.
Hi, everyone. Once again, trust we are all doing great. So it's actually, just confirm you can hear me.
We can hear you.
Oh, it's actually a pleasure for me to take this instead of our section officers, and I'm so delighted we're having this session because it has the idea or the topic of data analytics has actually transformed a lot of our lives, a lot of our career trajectories and a lot of innovative moves, right, in recent times, right? And data analytics is something that is ingrained in everything. So knowledge of data and knowledge of data analytics, no matter how small, will go a long way in helping everyone in any career, whatever career path you choose to take within the oil and gas, within and out of the oil and gas industry, because data is everywhere. Data, like Victoria rightly said, data is the new oil, right? So data is everywhere, and one way or the other, we need to analyze data, we need to gather data. So it's actually very profound, and it's actually very good, timely that we're having this session, especially for we in the oil and gas industry. And the basics, and it's a very good thing. It's always good to start from the basics. Once you understand the basics, to build onto the next level won't be difficult. Once you have the basics of your analytic skills, it just helps to just keep building and building using more advanced softwares and all that and all that. I'm glad that the facilitator is someone who has actually been building. So it's a testament of, so it's someone I know very well, and I know and I've seen how far he has come in his career as a data analyst, and I believe he'll be able to relate with every one of us as well and come down to a level to make us really understand the fundamentals of what we need for this session. So I will encourage everyone, sit back, sit tight, and just listen, learn, and I believe at the end of this, we would all have at least one thing to take home, and one practical idea or one practical skill we can take back to actually help us in whatever space we are, whether we are students or you're professionals or senior professionals. Thank you so much, everyone. Have a wonderful session ahead.
Thank you very much, Paul, for those insightful remarks. Like, you're going to learn the fundamentals for data analytics in oil and gas operations today. So now we move into the core of today's event, and it is my pleasure to introduce our speaker, Mr. Chinedu, CEO, Technicraft. He's going to speak on data analytics fundamentals for oil and gas operations. So let me introduce our speaker to us. Chinedu Nweke is a petroleum engineering graduate and data analytics practitioner with a strong focus on applying data-driven thinking to operational decision-making. He is the founder and CEO of Technicraft, a digital transformation and analytics firm that helps organizations simplify reporting, automate processes, and derive actionable insights from data. With hands-on experience in data analytics, Excel, VBA, automation, and performance reporting, Chinedu has designed and deployed data solutions used by schools, businesses, and professionals to improve efficiency, accuracy, and decision quality. His work centers on transforming raw operational data into meaningful insights that support planning, monitoring, and optimization. Chinedu has trained and facilitated learning for 400 plus professionals and employees across multiple sectors, helping them build practical data literacy and analytical skills for real-world use. His engineering background enables him to connect analytics concepts to operational realities, making data tools more accessible to technical and non-technical stakeholders alike. He is passionate about advancing data literacy within education, engineering, and industrial environments, and equipping professionals with the fundamentals needed to leverage analytics in today's data-driven economy. Ladies and gentlemen, welcome Chinedu Nweke, our facilitator for today.
Hello everyone. Good afternoon. Good afternoon. Thank you so much. Please confirm if you can hear me.
We can hear you,
Thank
but
you.
not
It's
clearly.
okay. No, I'm not audible.
Yeah, this a little bit of crack.
Okay. Is it better now?
No, it's not.
Let me try again. Sorry. Okay. What about now? Is it better?
I think we can manage with this.
Sorry.
Yeah, it's better now.
Okay. Thank you. Just anytime it's down, just let me know. All right. All right.
Uh,
Thank you so much. Thank you so much, everyone. It's an honor to be here. Thank you, thank you, thank you so much. Thank you for the introduction. Yes, so I would like us to dive right in. Okay. All right. So I would advise you to get your pen and your book, and then even as we begin to journey into the world of data analytics. All right. So I'll share my screen now. 15 minutes. Can you confirm if you can see my screen?
Yes, we can see your screen, but we appreciate if the audio, like your mic can
Okay,
be clear.
how about now? Is it better?
Yeah, we'll manage
Like
this.
it's very low, right?
No, it's not low. I don't know, maybe there's
Background noise.
no background noise, a brush with the mic you're using.
Oh, okay. Give me a minute. Right, sorry. Um, how about now? Is it okay? Can you still hear me?
Yes, we can. You can just continue.
Okay, okay. All right, thank you. Okay, so moving forward, can I see my slides, everyone? Please confirm if you can see my slide.
Yes, we can see your slide.
All right. Thank you so much. Good afternoon, everyone. It's an honor to be here once again, and I'll be taking us through data analytics fundamental in oil and gas operations. All right. So, okay. Okay, so we've done the introduction already. So, our expectations from this webinar, we will understand the core analytics concepts, how to apply analytics thinking to oilfield operation, how to perform operational analytics in Excel, and then how to develop a data-driven engineering mindset. All right, so before we begin to go into our tools, I would love us to have a background understanding, right? So, like Victoria said earlier, data is already referred as the new oil, right? But unlike oil, data is renewable and gets more value, it's more valuable when you use it, right? So data is basically in every single sector, basically. But then in the oil and gas industry, the oil and gas industry generates over 1.5 terabytes of data daily, right? So this, I believe that this lecture will give us a strong background on our journey, right, in being a data analyst. All right, so okay, so sit tight as we take you on a journey to becoming data smart. So first of all, um, before we begin to dive into data analytics, there is a part called data literacy, and what that means is, anytime someone talks to you about data analytics, the first thing you're thinking of is Microsoft Excel or Python or SQL, or there are so many other data analytics tools. But then the major thing, right, is having the mindset and then knowing how the workflow of being a data analyst works, right? So from there, we have like 85% of executives believe that being data literate will be as vital in the future as the ability to use a computer today, right? So that is a clear fact, right? So, like I said, mindset. So, tools changes, right? They evolve and technologies come up every single day. Come on, now you know that AI is actually taking charge, basically. Excel Python, you do not really even have to basically master the syntax before you begin to even use AI to generate things or to make work easy for you. AI is present to make work very easy. I know that some of us might have heard of vibe coding, vibe design. That's when you use prompt engineering to generate to generate answers and just to get things done for you. So basically, the idea is tools change, right? Technologies evolve every single day. Meanwhile, the soft skills, which is internal mindset and approach, are transferable across any sector. So just like what Paul Alabi was saying, that being a data analyst is a skill that is transferable across any sector. Why? Because there's no sector that doesn't require data, right? So here, if you might want to take this down, here are the major data skills. The first one is critical thinking. Okay, critical thinking. This is how you approach problems logically to determine which questions to ask. Sorry, which questions to ask and which data to collect. Right? We have analytical thinking, we have data story and communication. This is how you explain, right? These are because basically the reason why you are analyzing data is because there are stakeholders that need information from you. And so one of the very vital one of the very vital skill that you must have is communication skills. So is data being a data analyst is not just about learning how to use MySQL and Power BI. Yes, we know that Power BI helps you to tell story with data, but then you must be able to basically understand how to communicate. Okay, and then we have problem solving, the business acumen. This is understanding the specific industry context, whether it's finance, healthcare, oil and gas, as we are now, and then collaboration. A data analyst is a collaborator. You are discussing with stakeholders, you are speaking with business analysts, you are speaking with the technical team, and also it's more like a cross-functional role. Okay. So let's move forward. Data-driven decision making. So data literacy or analytics is completely irrelevant if it does not propel action. So like I said, you can analyze data, right? And you can give the stakeholders a an information. But the reason why you're there as a data analyst, even in the oil and gas industry, is to bring insights to the end that those insights will be used to make decisions, like actions will be taken from those insights. Are we together? Right? Actions will be taken from those insights. And that's why the goal of data analysis is to translate raw data rather into meaningful information, and using the information to inform data-driven decisions. That's action, right? So now here, this is how it evolves. This is how the data-driven decision-making model is. Obviously, from its first hits, right? Just the way we say, um, um, this is more like a life cycle, how data moves to action. So data needs states. Data has no little value like oil. It has to be mined. Information, after the data has been managed and analyzed, right, becomes information, right? Insights, those are the findings you get from analysis, and action is what brings the results. Okay, let's move fast. And so this is how, just like this is how it is. For the data, for example, when you're communicating in the oil and gas, you said A produced 4,200 barrels in January, right? That's one. Then information. Now this is the detail. Well, A produced 4,200 barrels in January, down 18% from December. Now there is some context and some story behind the data. I don't know if you understand. There's a story behind the data. Just like when you're using ChatGPT, ChatGPT will not give you accurate feedback when you just ask it to do something. You have to give it some story, you have to give it some context, and that's what information here is. And then insights. The production decline correlates with increasing water cut and pressure drop. Now, this is an insight. And then the action is recommend well intervention and water shut off diagnostics to prevent further decline. Now you can see how this data, right, moves down here to action, to insight, and then to action, because data is relevant because action wants to be taken. Am I still on the call? Can you still hear me? And am I audible?
Yes, we can still hear you well.
Okay,
Yes, we
thank
can
you.
hear you. But I don't know, there's a bit of a crack in your audio. I don't know, is there any way we can make that better?
Okay, so let me attempt
Is
that.
this a bit of yes, I think that would make it more audible. But we can hear you regardless though.
Okay, just give me a minute. Let me try and see if I can fix that.
I'll be very helpful, thank you.
Can you hear me now?
Yes, very, very much better. Thank you so much. I think we're good
Oh,
to go.
great. Thank you. Sorry for the obstruction. All right. Okay, so let me go back to sharing my screen. Okay, so let's continue, guys. So let's move forward. And here, so these are the different the data skills for energy oil and gas professionals. Well, you can see the different aspects or the different scenarios that they can represent here. So a drilling engineer uses historical rates of penetration, mud weight, and formation data to optimize well planning and reduce non-productive time. So this part of the slide is just showing us the different to show you that every single professional in the energy sector, if it's the HSC or the supply chain analyst, actually uses data, right, to get informed decisions. So that is basically what this is saying. So data literacy. Now, these four things is what we're going to be anchoring on before we even go to the analytics part, which is what we are doing today, right? The analytics part, and then we go to the practical session. Okay, so data literacy is the ability to interpret, manage, analyze, and communicate with data. Okay, interpret, manage, and these four things are the major anchors for this: data interpretation, data management, data analytics, data storytelling. Okay, so let's look at them one by one. But first, let's look at the types of data. We have structured data, unstructured data, semi-structured data. What is structured data? That's data in basically data in tables, rows and column, database or spreadsheets. We also have, sorry, we also have the characteristics. They are fixed, that's they have column names, they have data types, right? Data types like index, strings, and all. We have they are machine readable, right? We have relation examples of structured data. We have relational database, we have spreadsheets, we have CRM systems, we have transaction records. Then we have unstructured data. Structured data lacks a predefined format or organization. It is often text heavy, but can also include images, videos, audios, and other forms of data that don't fit into traditional databases. So that is an example of unstructured data, right? Characteristics, like I said, no fixed schema, the structure is not defined, it's often requires human interpretation and advanced tools. Okay, examples of unstructured data, we have emails, right? Social media posts, customer reviews, Word document. These are images, videos. This can't fit in a row and a table, so that's why it's unstructured. And then quickly, semi-structured is a mix of both structured and unstructured data. Example of semi-structured, we have JSON files, we have email letters, we have XML files, we have log files. Okay. So I'll skip this. So the examples, so for structured data, for example, this is a production data, right? It is structured because we can see here that we have a table here, the date, this is production, the well ID, the oil production, and then the gas production, right? This is just showing you examples of structured data. It is structured because it can fit, it can be written in a fixed schema, right? And then we have financial data, also an example of structured data. Then for unstructured data, right, we have geological reports. These are text documents describing geological formations, right? Drilling logs or seismic interpretations. We also have, example, a PDF report detailing the findings of a seismic survey. So we can see this. We also have the sensor data. This is raw. These are raw data from IoT devices or sensors such as vibration, temperature, pressure readings, and so on and so forth, right? We have multimedia data, images, video of a pipeline from the sites and all of that, okay? We have email and communication. And then for semi-structured data, we have log files. So we can see here, logs from drilling operations, equipment maintenance, or software systems. Example is a log file from drilling a rig, right? From a drilling rig, this is a log file. So you can see here, info, drilling started at this, the warning. So all of this data is connected and to this well, this particular well. So that's why it's a semi-structured data. Also, we also have data about equipment such as maintenance, schedules or specifications stored in JSON or XML format. All right, so basically, right, when we get data or when we get data from different sources, right, from a website or even from the field, we always want to be able to interpret the data and then to manage it. So that process of seeing the data, managing it, we have to clean the data, and then before we can even begin to analyze the data. And that is what we're going to be looking at, right? So yes, making sense of operational data. So interpreting data means making sense of operational data presented in tables, dashboard, time series, and all of that. You have to detect. Okay, so let me move forward. Recognizing a steady increase in pump variation as an early indicator of equipment failure. So in the identifying abnormal pressure drops during drilling as a potential tip of formation issue. All of these would actually be able to see them right later, and then detecting declining production trends before they become critical. So data management, this is just basically understanding how field data is generated, right? Sensors, SCADA, logs, manual reports, and then assessing and working with structured and unstructured data, handling different storage formats, Excel files, CSV databases. This is just you managing the files, your data, right? And then the examples would look at it. So one very important part of data analytics is quality assurance. Okay, it's a critical step in data analytics workflow and involves identifying and correcting issues that could potentially skew your results or findings. What that means is that no matter how much your data is, it can't actually completely validate that you would get the right feedback. So what that means is data quality is much more important than data size, like the volume of the data. So that is one thing that we actually have to put at the back of our mind. So this is a systematic process of verifying, validating, and cleaning data to ensure it is accurate, complete, consistent, and reliable before analysis, preventing misleading insight and costly operational decisions. So we know we are working in the oil and gas sector. We cannot, as data analysts, one of the things we want to do is to make sure that whatever data we are using, right, whatever data we are going to be using is accurate. Although when we import them into our analytics tool, basically there would always be a need to clean the data. And that's why data quality that's why quality assurance is very important. This is the part where you begin to refine the data, not even analytics, just to clean the data and make sure that yet it is good enough for you to now begin to carry out analytics operations. Okay. Now these are the common quality and quality assurance problems. So here, the first is incorrect data types. Now, if you see clearly from my screen, incorrect quality data types. If you see here, we have dates, we have the well ID. Sorry. Yeah. You can see here we have the dates, we have the well ID, we have the field name, different columns. Obviously, we know that this is a structured data. Now, incorrect. This is color. Now, if you can see from this column, we can see that this is supposed to be a string field, right? This is supposed to be a string field where we have names of different fields. But now here we are having weird values here. Now, this is incorrect. This is also incorrect. So there are cases where in your data, right, you will notice a whole lot of incorrect data types, right? And so you have to be able to carefully detect it. So the solution to do this is to what? Is to format or re-encode the fields to ensure accurate, consistent data types. Now, what are the kinds of values that we can have that we know that can have this kind of problem? Is phone number. You know, most times when there are different ways you get just example like a basic form, right? A basic form. When you're filling a form and you ask for phone number, when you are filling a form and you ask for phone number, there is always some people enter the phone numbers with plus, why some enter normally, right? So those things can cause the data to not be sorry. Those things can cause the data to be incorrect while you are analyzing them. So that's why it's very important for you to check for this, right? The next thing is duplicate records. This one happens all the time. This one happens all the time when you mistakenly enter records twice, or sometimes it's not even basically your fault. Maybe they were entering a record, probably from a production or something, and then it was entered twice. It is your job to actually be able to see and detect this kind of thing. And of course, you know, the function that we used to do that in Excel, we have a concept that is duplicate values, right? Duplicate values under conditional formatting. So you could just analyze when you select the data range and then you click duplicate values, it shows you the values that are duplicate. And mind you, the solution for this is to delete redundant records to avoid inflation on bias. Now, mind you, if you notice here that this row and this row, they are exactly the same thing. Now, it is possible that you notice duplicate records when you have similar rows, like every single data, like every single value in that row is exactly the same thing. That's why you know that there's a problem. And then the time you can see, that's when you know that there's a problem. But when you have like duplicates, for example, if the oil per barrel is this is 804.86, and the oil per barrel for this lower road is also 804.86. And all these ones are different. We can't detect that as a duplicate value. Most time duplicate values happens when the entire row is the same. That's when we know that yes, we have duplicate values. Can we still hear me? Am I still audible?
Yes, sir, we can hear you.
All right, thank you. So another type of quality assurance problem that we have is inconsistent categories. Inconsistent categories. What that means is that when we have, for example, you can see this well ID here. It's supposed to have like a structure, but now we are having different structures. Well, O8, well, O4. There has to be it's supposed to be unique. Either it's WO2, WO3, WO4, WO5, WO6, and all of that. So the solution is to get the standard and use find and select to replace them, right? So for example, we'll see more of that when we get into the practical. And then empty values. Empty values, you have this a lot. So here are, when you see empty values in your data sets, you would know that, okay, you have to actually fix it. So how do you fix empty values? So when do you retain empty values? You retain if empty values are accurate and don't skew your analysis, you retain it. That means you keep it. You leave it the way it is. For example, for this three now, you leave it the way it is. Now, input, if you can populate or estimate the data, then you impute it. That's what I mean is, if you can get the actual value, then obviously go ahead to enter that. And then remove, when you should remove, if you have a large data set and can't update the empty value, then you can remove it. Okay, so basically that's one of the ways you deal with empty values. And very, very important, it is advisable not to write zero. For example, now you might think, okay, this is empty, I should write zero. And you know zero is a value, and you writing zero can actually influence the analysis. It can totally influence it because other values have data. So if you write zero here, write zero here, you might think you're just solving the problem, but you are adding to the issue. Okay, so that is that. And then the last, we have outliers, right? Outliers. Now, outliers are basically values in our data that are beyond, right? They are just outrageous, right? They are just outrageous. For example, now you can see from my data here, the oil barrel, you can see that this is 389.64. You can see a consistency in the value. You can see a consistency in the value. And then all of a sudden, you're seeing this. You know that, yes, there's a problem. This is an outlier. If you don't deal with this, you can have an issue. So how do you handle this? If the outlier is valid and its impact is relevant on data, then you can keep it if it's valid. Okay. How do you impute by substituting? Now, if you want to now enter the value, now we want to now know, okay, how do we now get the accurate value? If this is an error, how can we fill it? It's simple. Average, just get the average of the column. That's if, sorry, just get the average of the column. So we have this column, can just do the mean, and then you know that the mean is the average, and just fill it. That's one of the ways you can actually deal with this kind of issue. So you do not have, you know that the mean is like an average. It's something you can always have. That's why it's the mean, something you can always have on average, and then you can just use it to replace the outlier, and then remove it if value is outrageous and significantly skews the analysis. Okay, so we have moved from data inspection, inspecting data to cleaning the data, and then we want to move into data analytics. Okay. I don't think there's any point defining this, right? But we know that data analytics is process of collecting, cleaning, transforming, and analyzing data to uncover patterns, generate insight, and supporting. This is just grammar. All you have to do is, as a data analyst, know the problem case, know what the stakeholder needs, like know the results that we want to get from data. And then when you know the problem, you'll be able to ask the right question, and then you know the problem, what is the company trying to achieve? What are we trying to see? And then from there, you have the data the company's data, and then you can now begin to use data analytics concepts to refine the data and then to present the outcome. So we have looked through this already. Okay, we have looked at all of these data collection. We have different sources of data. Yeah, we have looked at that already. We have the data cleaning where these are the different ways you fix it. So explorative data analysis. Let me just move straight to yeah, different types and techniques of data analytics. This is data visualization. So we'll get there when we get here. So data collection and sources. So these are the different sources of data. In the oil and gas data is collected from a wide range of sources, including sensors, databases, surveys, and more. We've looked at this before. Internal source. These are data sources within the organization. They are typically more accessible and reliable, right? We have external sources. We have the difference and then the importance. Okay, so let's move into this types of data analytics. So we have descriptive data analysis, we have descriptive analysis, we have diagnostic, we have exploratory, we have prescriptive, and we have predictive. Okay. What's descriptive analytics? So descriptive analytics focuses on summarizing and describing historical data to understand what has happened in the past. So this one answers the question, what happened? What happened? So you're given a set of data and then want to know what has happened in the past. That's where you use descriptive analysis. And so the concepts you use here are just basic: mean, median, mode, standard deviation, bar chart, pie charts, line graph. And see, it provides a current snapshot of the current states here or past performance. Okay. So these are the tools you use. We use Excel, we have used Tableau, use Power BI, we use SQL. So exercise. All right, so I think this is where we begin to dive into a little bit of practical. Okay, so for example, we have been given a scenario here. It said the production team are we together? Are we still together?
We're together.
Oh, okay, great. Yes. So we have a problem case here. So the production team at NNPC Offshore Oilfield wants to understand how their oil production has performed over the past 6 months. Now, remember, this is fundamentals, right? Having this background knowledge would set the stage for you to actually dive more and deeper into data analytics concepts. But one of the things that I want to establish is for you having the knowledge of knowing how data analytics works, right? And then know how to solve practical problems, and then you'll be good to go. So the production team at NNPC offshore oil field wants to understand how their production has performed over the past 6 months. As part of the business analysis team, you've been asked to present insights on production trends and help leadership make strategic decisions. So we have been given a simple data here. Now the question is this is the question. We said how has this performed in the past 6 months? How has this performed in the past 6 months? So we have this simple data here. So In the month of January, we have this 120, 110, and all. Now, the idea is this. This is just a normal data. We can actually show this to the stakeholder and say, okay, this is how the data performs. On January, we had this, February, we had this, March, we had this, and then you're just talking and telling the story. But this is not visually appealing. What that means is that at first sight, the stakeholder is trying to trying to skim through the values and say, okay, which one is the highest? And you're looking 120, okay, 110, 135. That's wasting time, and that's giving the stakeholder a problem. So we want that. This is where data storytelling comes into play, and this is why those charts and graphs is relevant for you to be able to communicate effectively with the stakeholder, right? Okay, so yes, so here is it. And then your task is, we've been giving the problem statement and we've been giving the task. The task is basically to create a bar chart, right? Create a bar chart or a line graph to visualize the production, and then to find the mean, median, standard deviation, and to interpret the data. What is the highest and lowest production month? How consistent is production across months? Okay, and we'll be able to solve the problem. How do I give room to twice? I don't know how long. Hello, can you hear me?
Yes, we can hear you.
Okay, yeah. So, okay, so let's move further. So we have here our data, right? And then this is actually the most basic form, right? This is actually the most basic form of it. So here we already have this here. Okay, we have our data here already. Okay, and this is our data written down here. And the question says, how has production been like? So this is a simple way of getting to analyze it, right? How do we get the chart? This obvious, I don't know if there is need to go through the Excel interface, because I'm assuming that we know how to walk through it. But then these are different tabs, and then you can always find what you need. It's just for you to hover on it, and then a dialog box shows and then tells you what exactly that does. Okay, so for this information, we've been given this, and then how do we do that? We just highlight and then insert just to create the data. Now, when you're presenting this to a stakeholder, you are telling a better story here. Rather than just showing this, now you are showing visuals, and then the stakeholder can easily detect that this is the highest. This is 140. This is the highest. Now, why do we have to find the mean? This is another part here. They said we're asked to get the mean, median, and the standard deviation. Now, for the mean, after when we get this, right? After when we get this is this interpretation for mean. Now, what mean tells us, basically, because they said we should find the production, how the production has been over time. So when we find the mean, of course, we know this mean is average. So the function for doing mean, for getting mean, is average. You can see here. And anytime we want to write a function in Excel, we always start with the equal to sign to write a function, and then write average, and then we can select this and then get that. Now, this is the mean. What the mean communicates is this. The mean shows that the average mean is the average production over time. Now, this is the baseline production target for future months. So that means that if if we are going to, this is the range at which we'll be expecting production. The median is the typical production month resistant to outliers. So when you have values or errors, potential errors, the median is just for you to like pick a sample and then be able to know that, okay, a more reliable central point, especially if there are unexpected low output months. So for months that we have low production, median can just tell us that, okay, this is actually a central level of our production is to be. And then standard deviation, like we know what standard deviation is production volatility. So this is how consistent production is. So an higher standard deviation suggests the need for operational stability. So for example, now, if you look at this mean, when you add the standard deviation to the mean, what that standard deviation, it's just saying either you add or subtract. So it's saying that if you are the minimum value that you can actually have, that's what the standard deviation is. So it's saying that the lowest production we should be expecting is just you subtracting the standard deviation from the mean. So if you are expecting low production, we will know that, okay, this is the value it's supposed to be. If we are expecting high production, we'll know that, okay, this is the value it's supposed to be. And that's why they said if the standard deviation is very high, that means there's a need for operational stability. Imagine if the standard deviation is 20,000. If you subtract 20,000 from the mean, it shows instability, right? It shows that, okay, at a particular month, January, a particular month, say you had 150. Let's say in January you had 150, and then February you have 100 or 90. You know that there's a problem with the stability of data. So that's what standard deviation basically helps you to know. Yes, I don't know if I can open the floor to get questions before I continue moving. Before we move to the next concept. And
I think the question and answer will come when you're done with your session.
Oh, okay.
Thank you very much.
All right. All right, moving forward, we have the diagnostic analysis. So the diagnostic analysis is basically focuses on understanding why something happened. That's what diagnostic analysis talks about. It digs deeper into the data to identify the causes, the patterns, and relationships, and it answers the question, why did it happen? So descriptive analysis answers what happened. So that's where you are using historical data. What happened? What's the state of our data? And then diagnostic analysis answers the question, why did this happen? Okay, so sorry. So key features, it identifies correlation and causal relationship between variables. The techniques, it uses drill down analysis, root cause analysis, and regression analysis. And then it helps to uncover underlying reasons behind trend and anomalies. So it's more like you working as a detective, right? So for example, when you're analyzing why production dropped in a specific well, so is it due to equipment failure? So this one, like I said, diagnostic, you want to know why something happened. Okay. You want to know the reason why there was production drop. So in the first case, when we are solving this problem, we just said that, okay, here production dropped. In January, production dropped, fine. January we have this. February we have this. We are seeing the fluctuation in the data. And then we can see, okay, what's happened? What's the state of our data? But now for predictive basically, not predictive. Diagnostic basically want to determine why it happened, why so and so thing happened. And that's why that is another part of diagnostic analysis. And of course, for this, you use Excel, you use Python, use R, and you use other SPSS and SAS. Okay. So let's move to the practical exercise for that. So for diagnostics analysis, practical example. So look at the problem scenario for this kind of diagnostic analysis. They said in May, the production team noticed a significant drop in oil output. In May, production team noticed a significant drop in oil output. And the director wants to understand why. Okay. Are you seeing that data analysis is relative to solving problem? It is relative to answering questions. You cannot separate the work of a data analyst to the work of the business. What that means is that most people think that data analysis is just you having to learn how to analyze data, but you must actually have the business acumen. You must be familiar with what the business wants to achieve. For different set of persons, how they interpret, how they work with data is different. For data analysts, I know you'll always be working with data, but the stakeholder or the owner of the business doesn't have any business basically with the large chunk of data. He just wants to know how that impacts his own finance or the investment that has been put in the company, right? So yeah, directors want to understand why you've been tasked with investigating the rate cost using historical data. And then this is the scenario. Now we have more data. We have January, we have the different production, we have the downtime, we have the number of workers, and we have weather conditions. Now, the more the data, of course, the more we can actually know what's going on here. And then we can now predict and know, okay, why is there a reduction in the production, right? So here we have 120. Why is there a reduction in production? And that's why this extra data was now introduced. Number of workers, the weather condition. These are the things that we know can affect it. So your task as the data analyst, you have been asked to create a clustered column chart showing the production and downtime using a secondary axis for downtime. Now, what that means is this, right? This is what we're saying in this case. We want to be able to compare the production and then the downtime, the hours, downtime hours. So I have that data here already. So let me show you how we got to this. Okay, so this is it. We have our months, we have the production, we have the downtime, we have the number of workers, and we have the weather conditions. Okay, so we want to compare this. So what do we do here? We are using a clustered chart. Cluster chart is just basically what we are merging two charts together. Okay, so we want to merge the production and the downtime. So after we select this, then we do what? We insert, and then we are inserting a chart. Sorry. Sorry, guys. Okay. All right, sorry for that. Okay, like I said, when we select this, we insert our chart. Okay. I want to use a cluster chart. Yes, here. Insert our chart. And then when we insert this, we have this here. Now, because we want to now you can just see only the production. You can only see the production. Why is that? Because obviously we can see that the production value is way higher. And then it's starting from 0, 20,000. Yeah, 20,000, 40,000. There is no way the downtime downtime can even appear because it is way far. So that's why we want to identify the relationship between the production and the downtime. And so that is why we use the that's why we use the clustered chart to compare this. Okay. So sorry, I do not know why this is malfunctioning. Okay, let me save this. I think I have seen the problem. Let me save this. Yes. Okay. So we do this, then we insert cluster chart. Okay. Then after inserting that, we have this. And then we want to convert this downtime chart to a line chart. And then to do that, we use combo box. This function here, this is where we combine it. And then for the downtime, we look at it. It's currently a line chart, and it's a line chart. It's not visible, so we have to click secondary axis, and then we click OK, and then this works. Now, from here, from the interpretation of this, we can see here that when we have, what this is saying basically is that for January, right, the downtime is 10, and then we have a high level of production. Now, if you look at this part where we have a very, the downtime hours was low, we have a very high production. Downtime is just basically we can say downtime is the time that was just a break, like the break that was taken by the workers. So for example, now 5 hours was taken by the workers, and we can see that just because 5 hours was taken in the month of March overall, that's why we have higher production. So we can see from this chart that the downtime actually affects and reflects to the production, the way the production is. So lower downtime here shows that there is an increase in production. A higher downtime here, which is 35, shows that yes, there's a relationship between this, and we have a lower production here. And that's just basically what this helps you to do. Okay. Yes. Okay. Now, the next question we asked to solve is the correlation. I want to be fast so that we can round up the session. So correlation, use the correlation function to check correlation between downtime and production. Now, most times correlation, like I said, what correlation basically means, or we have the function correlation, more like to correlate, returns correlation coefficient between two data sets. Now, when you're working with data and then you have values in tables like this, you have different values in table. Correlation basically wants to show you or tell you if there is a direct relationship between two set of variables in your data. Okay, now when I did this correlation, now I want to check the correlation between production and downtime. Now this is the formula equals to correlation production this, comma, downtime. Okay, and then we close the bracket. Now we have a negative correlation. What negative correlation means is that yes, there is a significant. Now, negative correlation means that when this is moving to one side, like if this is moving to the right, this is moving to the left, meaning they are oppositely correlated, meaning that as the production is increasing, the downtime is reducing. I don't know if that's clear. Basically, that's why it's negative. Okay, that's why it's negative. As production increase, downtime reduces. So that's basically what correlation is, to validate relationships basically between different columns, or yes, column values within your table. That's what correlation is. And if you are to check the correlation between the production and the number of workers, what we have here, you can see here the same thing, production and number of workers. From here, we see that, okay, total, we can see that the answer for this is positive. What that means basically is, as production increases, because it's positive, it means that both are heading to the same direction, same positive direction. They are both going north, or they are both going south, meaning production is increasing because numbers of workers is increasing. I don't know if that's clear. So that's what correlation basically helps you to validate. So you could have large numbers, right? Large number of columns of data sets, and then you might want to check correlation and say, okay, which of my columns have a direct relationship, and then that will not even give you an insight that, okay, this is actually what's going on. This is increasing and this is increasing. That you can now know. You cannot even identify see or validate the data quality. Do you understand? You can now validate the data quality. When you do the correlation, you now say, I'm not supposed to be having this. Imagine if this was positive. If this was positive, how is it that downtime and production is moving in the same direction? That means there's a problem. Or if this was negative, if production and number of workers correlation was negative, it means that number of workers increase and production is reducing. That's a problem, meaning that the workers they're not working basically. So I believe that's clear. And then correlation can be directly equal to 1. Anytime correlation is equal to 1, right? Then you know that there is no relationship. There's no relationship between, there's no valuable relationship between those between the data columns that you are working with. Okay. Yes. Yeah, I think that's basically it. Just to round up. So yeah, what factors might what factors might explain the production drop in May? We already seen the factor. There's downtime was high. How does downtime and workforce size impact production? So after you've done your analysis, then you can now type and then give a responsible feedback. Okay, so downtime impact. The strong negative correlation minus 0.85 shows that higher downtime leads to lower production. Weather impact. Stormy weather in February and May coincided with the lowest production month. Okay, that's just from viewing that, and then the workforce impact. Fewer workers in May also contributed to the production drop. Okay, so conclusion, the production drop in May was likely due to a combination of the following: increased downtime, stormy weather affecting operations, and lowest workforce. And then recommendation is to invest in equipment maintenance to reduce downtime. Obviously, there are a lot of things that cause downtime. It could be faulty equipment. So to reduce the downtime, we want to invest. So this is an advice you're giving back. This is an advice you're giving back to the stakeholders. Okay, we need to reinvest into the equipment maintenance so that we can have a more effective production. All right, and improve workforce scheduling and develop contingency plans for bad weather. Okay, we have exploratory. I think for the purpose of this, okay, yeah, I think we have just one more before we call it a day. Yeah, and for this one, I think we can, this is the last one, which is for the exploratory analysis. Exploratory analysis is the process of exploring and summarizing data to uncover patterns, trends, and relationship. It answers the question, what patterns or trend exist in data? So basically what this here is all about is that most times you can be giving data, and then sometimes even fact most times, right, there might not be you might not basically receive the request from the stakeholder that, okay, what's happening with our production? And that's why data is very important. So with the data that is within the system, you could actually begin to explore the data and then use the data analysis concept that you know to begin to check, okay, what is happening in this data? Okay, what can we do better? And then it's just you exploring the data to see patterns and then get insights to how you can make things better. And majorly the tools for this is Python, Tableau, R, Power BI. Okay, exploring EDA, that is explorative data, is that exploring a new city, walk around, observe the sites, patterns, and get to feel the place data before deciding where to go next. And here we still have the same scenario. So the NNPC leadership is trying to understand what factors influence oil production the most. You see, what factors, and they suspect that things like workforce size, equipment age, maintenance activities, and even weather conditions could play a role. Your task is to explore the data, visualize relationship, and uncover insights to help guide strategic decisions. So basically, it's just you playing around with data, and it still follows the same tax of the one we did earlier. I think because of our time, I would I think I'll stop here with the practicals. And then let me go back to this. Most times we have some set of data here. This is how raw our data is. Now we can see here that we now this is production data, for example. When we are working with data like this, most times it is advisable to always have the raw format and then create another sheet and then copy and then start cleaning data. What I mean is when you get data like this, Control A, get everything and then create a new sheet, right? And then begin to work on them. So in case um you make mistakes or you want to go back to your source, you can easily get that done. Okay. And then from here, we have some values that are not corresponding. For example, look at this is a problem, right? This is a problem. This is another problem. So we want to be able to separate them to be able to clean this data. And how do we do that? This is why for any tool, data analytics tool, this is this is basically not an Excel class. It's just to give you the background concept of how to work around data analysis and what it's all about. But to do this, that's why you have to be really familiar with whatever data analytics tool that you're using. In fact, Excel is one of the like major entry-level tools that every data analyst must have. Excel, Microsoft Excel is one of the entry-level tools. Why? Because it is completely offline and it's just something that you can just begin to work with on the go. Okay, so to clean this, we could use a normal that's a lot text to column data, and then we can use delimited next space, right? We can see this and we can click next and then finish. I'm not supposed to replace that, but let's just see. Now look at this. This has already given all of this a unique representation, right? So now this replaces our data. So one of the things we can do is just to insert a new tab, right? After we insert a new tab, then just go back and do the text column. So all of these are ways of, we talked about quality assurance is clinic data. So we want to always do that. Finish. Yes. And then now, because this is irrelevant, we can now delete this. So yes, that's basically, I think I will stop here because of our time. Thank you so much. If you have any questions, we can please ask. Victoria, thank you.
Thank you so much for this insightful session. You've said a lot, and a lot of things. You said so much. And one that even really stood out to me is how you said you can make recommendations based on the insights we've gotten from our analysis. So, and that's going to really resonate with me too as a data analyst. So thank you so much, Mr. Chinyere, for this practical presentation. So we'll now move into the question and answer session. Please drop your questions in the chat, or you can signify by raising your hand. Whichever one is convenient for you. This is our moment to ask our questions to gain clarity directly from our facilitator. Let's not be shy. Let's ask questions from someone who has real life experience. Then let's go back to be asking ChatGPT. Yeah, we can ask ChatGPT, but you can seize this opportunity to ask our facilitator. Okay. Please, Chinedu. Please, will you be able to share your slides with us after this webinar?
Okay, like to share the slide.
Yes.
Okay. Okay, was that the question that was asked?
Yeah, good evening from here.
Yeah.
Okay, can I go ahead and ask some questions?
Yes.
Victoria, yes.
All right. Yeah, okay. Sorry, I'm good evening from here. I'm actually streaming from Malaysia. So I really want to thank the speaker for doing justice to the technical session. So before I go on to ask my question, I just want to thank you for enlightening me on correlation. So I have been practicing data analysis for a very long time, but the concept of correlation has been one of the nightmare. I find it real hard to understand, but you actually simplified everything for me this night, and I really appreciate that. So now going to my question is, thank you. So when you're carrying out your analysis, can you use two data analysis tools, like maybe let's say Power BI, Tableau, or SQL, with let's say Excel, simultaneously? Can you use both of them? Like if you're doing your analysis, is there a way that you can use either Excel and together with any other tools, simultaneously whenever you're doing your analysis? That's what I want to know. Yes.
Okay. Amazing. So every tool has its strengths, right? Every tool has its strengths. And one of the strengths of Excel is different from the strength for Power BI. Power BI is majorly for like I said, business intelligence, majorly for visualization, right? It's better for visualization than when you're using Excel. Although if you have strong expertise in Excel, you can actually create amazing dashboards. But it's as if Power BI was majorly created for that, even Tableau. So when you're doing your analysis And there are some analysis that when you want to work with Excel to do that, you would have to go through a whole lot of steps. So for example, when I wanted to do the analysis with Microsoft, when I wanted to do this analysis to clean this data, I have to clean the data, I have to go through something, I have to look at it. But with Python, you could just write the code. In fact, Python for analysis, some of them already have libraries that handle some of those questions. Are you with me? So that handles some analysis. So you can just, it's more as if you are calling, those those libraries, and then it works on the data smartly. Do you understand? So
Yeah, that's true. That's true. Yeah.
great. So basically, the question of you wanting to use simultaneously, if for practice, yes, you could use it, but you would um but it's more advisable to use the one that would give you fast feedback. Do you understand? You give you straight your analysis, and it depends on your expertise too, the tool you basically know how to use. So I would say that majorly, like I said, one of the major entry level data analytics tool you can always find is Excel. But as you're moving forward, and as the data types, the kind of data you're having access to is like for large data now, like large data sets, Excel has a limit of handling that, right? And so you want to use Python to be able to do work on those analyses. I don't know if I answered your question, sir.
Yes. I think in the part of the Python aspect, where you can use Python to clean your data, I think you can import your data in Python, clean it there. You can now use that clean data maybe in Excel or Power BI. Now run your analysis.
Exactly.
Okay.
Exactly.
Thank you so much.
You're welcome. You're welcome.
Thank you so much, Mr. Chinedunweke. Thank you so much, Mr. Chinedunweke. So we have questions in the chat, and we have one more hands raised. So
Okay.
and that's from Wisdom. Wisdom, please,
Okay.
can you go ahead with your question? Wisdom. Okay, before Wisdom, unmute his mic. So someone.
Okay.
Oh, Wisdom, are you? Okay, yes.
Yes.
Wisdom.
Thank you very much, my boss, Jude. I was really, I learned a lot. Yeah, I learned a lot. And I think I learned some new things, especially as regards the correlation. So, but I don't know if I'm mistaken, because at some point when we were talking in the correlation, I was like in my own comment that, okay, when you say them, when it's positive, I think 0.8, it means there's a positive. That means as it's going up, this other one is going up, like direct proportion. Then if it's negative, you said it's the opposite way, like how the production was going up, but downtime was going down. That was negative. So, but my question was at the end, you now said that, but if it's 1, it means there is no correlation. So I don't know. I of the view, I said I will check it later, but since we are still on the call, if is it not, I wanted to now ask that if it is 1 and there's no correlation, what if it's 0? Because for my
did I
own
say
view,
1?
I feel it should be that way. So let me ask.
Yes. I think that was an oversight. It is 0. 0.
Okay.
0,
Thank you.
not 1. Thank you so much. That was it. Thank you. 0.
Okay, thank you so much, Wisdom, and thank you so much, Mr. Chinedu. We have another question here that says, thank you, sir, for this insightful lecture. I didn't really get the part where you talked about not adding 0 to your data.
Oh, okay. Yes, let me go back to this slide. Can you still see my screen?
Yes, you can see your screen.
All right. So, yeah, when I said not adding 0 to the slide, most times, right, when you get data from anywhere, from the source, or from where you get the data from, most times you will find empty values, like empty values. So for example, let me go back to the Excel sheet. Now see this, look at our Excel sheet. Now imagine if this is blank, this is blank, this is blank, this is blank, and then you have all of this blank, right? This is a problem. There are values here. And now, okay, in your data analytics mind, you say, oh, great, I can work with this. Let me just solve the problem once and for all, and I can just handle my data. I'm saying that it is wise not to use zero. Like, do not fill this with zero, because that is a problem. So the best way to handle missing values, like I said, is this. You must make sure that, okay, is either if the data, is either you use the average of the column. Why? Because when you look at the values are, they are between a range. Do you understand? They are between a range. So doing the average of the entire column and getting it. Now let's do for this now. Let me find the average of this entire column. From here, the average is, can you see the average? 222.192. And so we can just basically fill that. Look at, you see now, this is inconsistent value. That's why it's necessary. So for these empty cells, we can now fill the average, and then that's how we can, one of the ways we can solve the problem. Then wellhead pressure, the same way we do that, the same way we handle all of that. I don't know if I answered it. So basically, if I using zero is a value, you understand? Zero is a value, and that value, it can affect the answer or your analysis. So that's basically, it's wise not to use zero. It's better you eliminate it completely if you have a very large set of data. So yes, did that answer your question?
Okay, yes, that answered that question. Thank you so much, sir. Then another question, which I think is the last here. Please, can you shed more light on how data iteration can be done using Excel?
How data iteration
can be done, yes, using Excel.
Okay. Sorry. I didn't really get that question. Oh, I understand. Okay, that's an amazing question. That's an amazing question. In fact, I would say, so like you said, iteration is like more like, is it more like a template repeatedly applying calculations on data until, okay, so from the definition I have here, on repeatedly
Sorry, sir.
applying calculations. Yeah.
Yes, she
Go ahead.
said more like if there are a lot of data, you need to repeat certain operations.
Okay,
To repeat and
okay.
repeat and repeat, yes.
Okay. Thank you so much. So that's the part where we come. That's the advanced part of Excel now, called data VBA, Visual Basic Automation, right? That's the part of Excel that allows you to automate some task. Okay, so for the purpose of this, I would show us a quick 2 minute, just 2 minute iteration, okay, so that we can know. But one of the things I do most of the times is that, so Excel has a portion called the developer tab. So these are different tabs. We have the developer tab, and then there's a part called macro. A macro is basically a set of instructions that you would want Excel to repeat every single time. So, basically something, when you press Control C, you know that Control C is copy, Control V is paste. But then you can define a macro to be some certain instructions. And then when you now press Control Shift C, can now be to be like calculate the blanks or calculate the higher values. So that part, just, you can write this down. That part is called Visual Basic Application. In fact, I would say that that's literally my favorite part in Excel, because that's the part where I used data analysis. I used Excel to build applications within the whole environment. So most times you do not want to repeat tasks, you just use it to automate. In fact, VBA is another level, like is as powerful as programming. It's as powerful as programming. Most times you can even insert what's it called now? You can insert buttons, and then you can assign some functions to it, and then when you click the button, it just automates the whole thing. So for example, a basic automation process. For example, anytime you want to open your sheets, anytime you want to open your sheets, you want to open your sheet and you always write something. So this here is this. You can say new sheet, new sheet info. So the shortcut you can apply to this Control Shift S, and then this workbook, and say okay. So I record some instructions. If I press new and I press this and I press merge and center, and I say this is a new sheet. Kindly write the info below. And I know that this particular thing is something, okay, let me write this. Name, class, age, department, status. Yes, and I know that this is something I would always do anytime I open a blank sheet. I can, just like iteration, calculations, it can work for calculations, can work for anything. And I don't want to always repeat this every single time, repeat calculation. After I've recorded this macro, I can now stop it. Now, remember, this is sheet 4. Anytime I press Control Shift S, look at this is sheet 5. Look at what I recorded. This is sheet 4. It also has that. This sheet 5 also has that. Control Shift S again. Sheet 6. It also has that. So that's the same way you can basically do that. In fact, any single thing, like I said, understanding concept and all, you can literally tell ChatGPT to go through. You can take a prompt and tell ChatGPT. I'm talking about prompt engineering now. You can tell ChatGPT, okay, I have a data set. You sit down, write the data columns, the headers, and say, I have so columns. I need you to look through the oil per barrel column, which is the column D. I need to look through it. And I need you to add values for me, values that are greater than 500. Values that are greater than, and ChatGPT can literally, it will now look through, it will now give you data, right, of values that are greater than 500. And it will give you some lines of code. That lines of code, this is where you paste it. This is called Visual Basic for application. And then here you can insert, look at the one we just created now. These are lines of code. Look at, this is name, age. It's just like coding. I can decide to change this to any other thing. Let me say sex, which is male or female. And then after I do that, I can save. When I save, and this is another thing. Anytime you're working with automations like that, you have to save your Excel workbook in a macro-enabled workbook and then save that. And then anytime you have that written, you would always have that. So remember, it is Control Shift S. And look, you have sex this time. In fact, the power of VBA lies across a whole lot of sectors. You can literally build a full template and then reshare it and sell to different institutions. Either now you're working in the oil company, you can take a particular problem, or in the finance department. I know you always do financial calculations every single time. You can build a template, automate the template, make sure that, okay, when they enter this thing here, it's automate, enter this here, it automates, and all of that. I want to show us this. This particular thing you're seeing was built with VBA. This is an Excel environment. This is an Excel environment. But all of this user form you're seeing here that is simulating an app was built with VBA. That is the power of VBA. So I don't know. I believe I answered your question, right? Hello, am I still live?
Yes, you're still live.
So yes, did I
Yeah.
answer the question?
Yes, your question has been answered. Thank you very much, sir. Thank you for those engaging questions and responses. I believe data analysis is not something that can be covered in 2 hours. It's very wild. So I would encourage everyone to just read more, work more with data, with the tools, and just keep getting better at it. Thank you. So I want to formally appreciate our speaker for sharing his time and expertise with us. Thank you so much. And I'll now invite Edore Ogene Woro for the presentation of certificates. Can we get the slides back up, please? Thank you. Edore Ogene Woro, over to you. Edore Ogene Woro, can you hear me? I don't think he's on the call with us. Okay, please, the floor is yours. Yeah. Since Edore is not here, I would love to call on Willie.
Good afternoon, everyone.
Good afternoon.
Yeah, so I'll be taking this in his stead. So I would want to say a big thank you to our speaker and lecturer for today, Mr. Chinedum Weke. So on behalf of SP Wari Nigeria section, on behalf of the YP team, technical and career, we wish to present this certificate of appreciation to you for in recognition for your facilitating of our technical lecture on data analytics, fundamentals for oil and gas operations. You've really done a good job for someone like me, a beginner like me. I think you did a very good breakdown, and I was able to follow through to the end. Really appreciate and would like to have you more. Thank you very much, boys.
Thank you so much. Thank you so much. Thank you.
Thank you so much. Thank you so much once again, sir. So we now have a brief photography session. So kindly turn on your camera so we can capture this moment. I'm not seeing our faces. If you're in a convenient place to turn on your camera, it would be very nice. Thank you, Lucy. Come on. You're in a... Thank you, thank you, thank you. Yeah, it's so nice to see our beautiful and handsome faces. Thank you.
Okay, so good afternoon. Can we turn on our camera so that I could take the photograph? Okay, Temitope Ijoma Solomon. Please, can you turn on your camera so that I could take the photograph? So many persons have not turned on their camera. Oh, I don't know. Might just have to work with what we have.
Yeah, Patrick, please go ahead and let's work with what we have. Thank you.
Okay.
So we can do SP.
Yeah, the SP. Yeah.
All right. All right. So that's
Thank you so much. Thank you so much, Patrick. Thank you so much. So thank you, everyone. But before we wrap up, it's important to stay connected as a professional community. So I'll still invite Patrick to take us through our SP awareness and upcoming events.
all right. Thank you. Thank you, Victoria. So first, before I begin, I would want to please confirm you can hear me.
We can hear you.
Yeah. So I would want to appreciate Chinedu for the insightful technical lecture. Chinedu was my course mate back then, right? So it's actually a privilege to listen to you talk about data and the great work so you've actually been doing in that regard. So going forward, I would want to just admonish us to try and renew our memberships for those who haven't done that. And if you are not a member yet, if you are not a registered SP member, please do well to register because you stand a chance to gain so many benefits. You have first-hand internship, career information, mentorship programs, scholarships and trainings. You also have access to technical lectures, resources, a knowledge base, and also access to industry leaders and professionals. So it has so many benefits, right? So please just do well to register if you've not done that, and renew your membership as well, because it's also similar to the benefits. You stand to get a lot when you are a registered member, right? And I believe in the course of other activities we will be briefed upon upcoming events and technical lectures. So thank you very much, everyone. Over to you, Victoria.
Thank you very much, Patrick. Thank you. So it's clear today is not the end, and our journey as professionals continues. So let's endeavor to engage in our upcoming events. So to formally close today's session, I invite Ngwanyi Lucy for the closing remarks. Ngwanyi Lucy, over to you.
Good afternoon, everyone. Please confirm you can hear me.
Good afternoon, Lucy. We can hear you.
Okay, so this has actually been a very insightful lecture. So I would like to start by thanking our esteemed speaker, Mr. Chinedu Nweke, for his excellent and detailed delivery on this topic. Because as we all know, data analytics is becoming an essential tool for improving the efficiency and decision making in the oil and gas industry. And as SP members, some of us are already working in the industry, and some of us here aspire to also work in the industry someday. So understanding the fundamentals will help us to make smarter data-driven decisions that will shape a more innovative and sustainable future. So thank you very much, Mr. Chinedu Nweke, for your time and for telling us a lot about this data analytics. And I would also want to appreciate our amiable moderator, Ms. Victoria. Thank you for your time, and everyone who worked tirelessly to ensure the success of this program. Thank you all for your efforts. And finally, I would want to thank everyone who made out time to join this program this afternoon, because without your participation, this program wouldn't have been a successful one. So thank you very much for joining. And I would want to encourage each and every one of us to endeavor to, practice what we have learned here today. So thank you all, and do have a wonderful day and, of course, a wonderful weekend as well. Thank you.
Thank you. Thank you.
Good job.